Welcome. In this session, we'll learn how to determine the output of a network or system directly from the transfer function. Okay. Uh, let's suppose our system, network is this, and input to this network is x of t. X of t can represent voltage or current. Let's suppose this is A sine omega t plus theta. Okay, and our goal is to find y of t given transfer function h of s, given transfer function h of s. Now we can write the output of this system or network directly from this transfer function, and y of t you can write directly as y of t will be simply equal to. Now remember, if the network is linear, or if the system is a linear system, then output you can write directly from this input using the transfer function approach. Now output will be simply equal to A, and only amplitude will change, frequency of this sine wave will remain same, and phase will change. Okay, so what is different from input to output in this network? Now amplitude, instead of A, we have A1. Now A we already know, our goal is to find A1. Similarly, input phase is theta and output phase is theta plus phi. So the different quantity here is phi. So our goal is to find what's A1 and what is phi. Okay, these two quantities we determine from the transfer function. How? We say A1 is simply equal to the magnitude of the transfer function if we replace S by j omega. What's omega? Omega is the frequency of the source. Okay, so we can write it directly like this. So output is simply magnitude A1 is simply given by this. Similarly, what's phi? Phi is simply the phase contained in the transfer function if we replace S by j omega. So if we replace S by j omega, what's the phase? That is phi. So after we determine A1 and phi from the transfer function, we substitute here, we'll be able to find the output. Okay, very simple approach. Okay, so what's the first thing that we learn? We say that if the input is sine wave, only two quantities change from input to output: amplitude and phase. Frequency remains same. That's the first observation you can check. Frequency of this sine wave remains same, or this voltage source or current source remains the same at the output. Okay. Let's solve some examples to understand this concept. So let's suppose transfer function is given. Sometimes you may have to determine the transfer function first, and then use this approach. If the transfer function is already given, so we can proceed. So let's suppose transfer function S of S is simply S1 by S by 1, and input x of t is simply equal to, let's take it 10 sine t plus 45 degrees. So amplitude A is 10, omega is 1, and theta is 45 degrees. Our goal is to find y of t. Our goal is to find y of t, output of this network or system, for which the transfer function is given here. So what will be the output from this? Output y of t, we solve this, y of t will be simply equal to 10 times A1 sine t plus 45 degrees plus phi. From this function, you can look at this. From this only, we introduce two quantities, A1 and phi. Okay, to write the output. So if we have to determine A1 and phi here. How do we determine A1? A1 is the magnitude of transfer function when S is equal to j omega. So A1 is simply magnitude of S of S, and S is j omega. So using the value of h of S, S plus 1, S is j omega, omega is 1, so S put S equal to j. So this will be j plus 1. Now this is simply a complex number, and we know how to find the magnitude of a complex number. Magnitude of this complex number, simply magnitude of numerator is 1. Magnitude of denominator is 1 square plus 1 square, that is 1 by under root of. So a1 is 1 by under root of 2. Similarly, phi is the phase of h of s when s is j omega. So phase in 1 by s plus 1 when s is j omega, omega is 1. So when s is j, so angle contained in the transfer function j plus 1 divided by j plus 1. Phase of numerator is 1 because this is a real number. So 0 minus phase of denominator. Phase of denominator will be simply tan inverse 1 divided by 1. Tan inverse 1 divided by 1 is 1. So it will be minus 45 degrees. Okay. Tan inverse 1 is 45 degrees. So substituting the value of a1 and phi, will get the output. So output y of t. So y of t is simply equal to 10 times a1 sine of omega t. Omega is 145 degrees plus phi. So substituting the value of a1 is 1 by under root 2. 1 by under root 2 sine t plus 45 degrees. Phi is minus 45 degrees. So output is simply equal to, now we can write 10 divided by under root 2. If we multiply numerator and denominator by under root 2, it will be 5 under root 2 sine t. 45 minus 45 is 0, so it will be simply equal to sine t. So output for the input is simply 10 sine of t plus 45 degrees. Output of this network or system is 5 under root of 2 sine t. Okay. So if you look at the input and output of this network or system, we'll see only two quantities change from input to output. Amplitude gets modified. Now the new amplitude is this. Phase earlier was 45 degrees. There is no phase in the output. Okay. Only two quantities change. Amplitude and phase of this sine. Okay. Now let's take one more example. Let's suppose now input is, let's suppose input x of t is 10. Let me take this time cosine instead of sine. Let's take cosine 4t. Okay. And transfer function of this network is simply, let's suppose how much. So we'll take it 5 divided by s plus 3. Okay, the transfer function of the network is this. Our goal is to find the output voltage or current y of t. Okay. All right. So how do we write the output? So solution will be simply y of t can be written as 10 multiplied by a1 cosine of, cosine and sine are one and the same. Only there is a 45 degree phase plus phi. Okay. There is no phase here. We'll introduce phi. Okay, so our goal is now find a1 and phi. How do we find a1? A1 is simply magnitude of the transfer function h of s when we replace s by j omega. So if we put s equal to j omega, transfer function is 5 divided by s plus 3. Omega is how much? 4. So if we replace s by 4j, we'll get from this, so it will be 5 divided by 4j plus 3. So we have to find the magnitude of this quantity. These are complex numbers. So magnitude of numerator will be simply 5 because this is the real quantity. Magnitude of denominator will be simply 4 square plus 3 square. 4 square plus 3 square is under root of 25. So 5 divided by under root of 25, that is 1. Because under root of 25 is 5. So it will be actually 5 divided by 5. So that's equal to 1. Similarly, what is phi? Phi will be angle in h of s when we replace s by j omega. S is simply 4 divided by S plus, I think it's 5. 5 divided by S plus 4, S plus 3, not 4, 3. S plus 3. When we replace S by J omega, omega is 4 J. So if we substitute the value, angle contained in the numerator is 0 because this is a real number. So it will be 0 minus tan inverse. So if we put S equal to J for J, it will be 4 divided by 3. Now tan inverse 4 by 3, I think tan inverse 4 by 3 is 53 degrees minus 53.13 degrees. Please check this calculation one more time. So A1 is 1, phase is this. So substituting A1 and 5 here, we'll get the answer. So 10, A1 is 1, cosine of 4t, phase is minus 53.13 degrees. Okay, so if you look at the output and input, output we can write as 10 cosine 4t minus 53.13 degrees. So if we look at the output and input, only two quantities change. And this time the amplitude is same. Okay, for this amplitude didn't change, only phase change from input to. Okay. Now suppose we have 2 or more sources connected to a network, and we have to use a transfer function approach. Right? So we don't have one input, we have multiple inputs connected to a network, and our goal is to find the output. Suppose our input is 10 sine t, 5t plus 25 cosine of 3t. Okay. And suppose the transfer function of this network is transfer function is, let me take a very simple example, 1 divided by S plus 4. Okay. Our goal is to find the y of t. So what is y of t in the output of this network? As you can see, we have two sinusoidal sources connected to this network. Okay. So if we use the superposition principle, we can find the response individually. So for 2 sine 5t, what will be the response? Simply, it will be 2a1 sine 5t plus 5, because we have two sources. What will be the output corresponding to 25 cosine 3t? The corresponding output will be simply 25a2. Okay, I'm just changing the terminology. 25a2 cosine of 3t plus 5, 2. Okay, so for individual inputs, for 2 sine 5t, the output will be this. And how do we determine A1? A1 will be determined from this, replacing S by J omega. Now remember, omega here is 5. Similarly, what will be the output for 25 cosine 3t? Output will be simply 25 A2 cosine 3t plus phi 2. And our goal is to find A1 and phi 1, A2 and phi 2 from the transfer function. Remember, the frequencies of the two sources is different. Okay. Now, if we apply the combination, means if we apply both the inputs simultaneously, what is the answer from linear principle or superposition principle? Output will be simply sum of the individual responses. What is the individual response? They said that's the literal answer from the superposition principle. Okay, if we have multiple sources connected to a network, you can find the output like this. First, find the individual responses, then sum the individual response. Okay, so first let's find A1, phi 1, and A2 and phi 2. So transfer function is 1 divided by S plus 4. And let's start with A1. So A1 will be simply equal to magnitude of h of s when s is equal to j omega. So h of s is 1 divided by s plus 4. S equal to j omega. Omega in this case is 5, remember. So 5j. So put s equal to 5j. So this will be 1 divided by 5j plus 4. What is the magnitude of this? 1 divided by under root of 25. 5 square plus 4 square, that is 16. I think this is 39. Please check the calculation. 1 divided by under root of 39. Okay. What's phi 1? Phi 1 is angle in h of s, and we replace s by j omega. So this will be 1 by s plus 4. S is equal to 5j. So this will be, so not magnitude, angle. This is the angle contained in this. So angle contained in this, when we replace s by 5j, so this will be 5j plus 4. So what is the angle contained in numerator? 0, because this is a real number, minus tan inverse 5 by 4. Hope you remember the complex theory class. The phase in a complex number. Tan inverse 5 by 4 is 51.34 degrees. Please check the calculation as well. So A1 and phi 1 we have determined. Okay, this is A1 and this is phi 1. Okay, A1 is here, phi 1 is here. Similarly, we have to find A2 and phi 2. So A2 is the magnitude that we used. A2 is the magnitude of transfer function 1 divided by s plus 4 when s is j omega, or substituting j omega. Now remember, what is the omega for this case? Omega here is 3. Okay, omega for this source is 3. So replacing s by 3j, we'll get the magnitude 1 divided by 3j plus 4. Now this is a complex number. So magnitude of this complex number is, numerator magnitude is 1, denominator magnitude is 3 square plus 4 square. 3 square plus 4 square is under root of 25, so 1 by 5. Please check the calculations one more time. Now phi 2 is the angle in the transfer function. Transfer function is 1 divided by s plus 4 when s is j omega. Replacing s by j omega. What's omega? S is 3j. So if I replace s by 3j plus 4, so what is the magnitude, this phase of numerator? 0, because this is a real number, minus tan inverse 3 by 4. Tan inverse 3 by 4 is, I think, 36 degrees. Please check the calculations. 36.87 degrees. Please check the calculations one more time. So substituting the value of A1, A2, and phi 1 and phi 2 here in this expression, we'll get the output. So what will be the output? So output will be simply equal to, what is the input here? Twice A1. So twice A1 is, I think, 1 by under root of 39. Sine of 5t plus phi 1. 5t plus phi 1. How much is phi 1? Phi 1 is minus 51.34 degrees, minus 51.34 degrees, plus, what is the second source? 25A2. So 25A2 is 1 by 5 cosine 3t 3t plus phi 2. Phi 2 is minus 36.87 degrees. So we can write this as 2. You can simplify this. We keep it like this. 5t minus 51.34 degrees. 25 divided by 5 is 5. Cosine 3t minus 36.60. So this is the output of this network system if multiple sources are connected to this network. okay, with different frequency. All right. Now, similarly, we take one more example. If I say the input is now suppose 4 plus twice sine 3t. And transfer function of this network is, let's suppose 1 divided by s plus 4. Okay. Transfer function is 1 divided by s plus 4. How do we write the output function? Now we know we have a DC source and a sinusoidal source connected to this network. Okay. So again, using the superposition principle or superposition theorem, we can find first the individual response, then sum the individual responses. So our input x of t is equal to 4 and 2 sine 3t. So what will be the corresponding output for this? Because this is a DC source, so output will be simply 4 times A1, because there is no frequency, so there will be no phase. So it will be only amplitude will change. Similarly, what will be the output corresponding to this? 2 times A1, A2, let me write A2 sine 3t plus 5. Okay. Now, if these are the individual response, so if we apply both the inputs simultaneously, so the output will be the sum of individual response. So that is the statement of superposition. Yeah. So our goal is to find now A1, A2, and same procedure. Okay. So what will be A1? A1 is the magnitude of transfer function when S is J omega. Now, if you look at the transfer function, 1 divided by S plus 4, now what is the omega for DC? Omega for DC is 0, so S is 0. So if I put S equal to 0, it will be simply 1 divided by 4. So that's the magnitude. So substituting A1 here, we'll get the answer. Similarly, you know how to find A1 and A2 and pi here. So A2 is the magnitude of H of S, and S is replaced by J omega. If I, what is omega here? Omega here is 3. So S is 3J. So if I substitute it here, it will be 3J plus 4. So what is the magnitude of this quantity? Magnitude of numerator is 1. Magnitude of denominator is 3 square plus 4 square. And this under root of 3 square plus 4 square, that's what under root of 25. Under root of 25 is 5. So 1 by 5. Similarly, phi 2 is the phase in H of S when we replace S by J omega. So what is omega here? H of S, S is 3. Sorry, omega is 3. So it will be 3J. Omega is 3 here. So 1 divided by S plus 4. S is 3J. So this will be angle in 1 by 3J plus 4. So what is the angle in numerator side? 0 minus angle in denominator side. Tan inverse 3 by 4. Tan inverse 3 by 4 is 36, I think. Please check the calculations, 36.87 degrees. So substituting A1, A2, and phi 2 here in this expression, we'll get the output. So input is 4 plus how much? 4 plus 2 sine 3t. 4 plus 2 sine 3t. So the corresponding output is y of t. For this is 4 times A1. A1 is how much? 4 times A1 plus twice A2 sine 3t plus 5. Simply we wrote it 5 because there is only one phase. So what's A1? A1 is 1 by 4 plus what is A2? A2 is I think 1 by 5. Yes, 1 by 5. 1 by 5 sine 3t. What is phi? Phi is minus 36.87. Minus 36.87 degrees. So the corresponding output is this. You can simplify this. The output will be 4 divided by 4 is 1. So 1 plus 2 by 5 sine 3t minus 36.87 degrees. Okay. So the input is this, corresponding output is this using the transfer function. Okay. Now in all these examples, transfer function was given. Sometimes you may have to determine the transfer function and proceed with this procedure. Okay, very simple. And we have named the input generally as x of t and y of t. These x of t and y of t may be current sources or voltage sources, depending upon the net. Accordingly, the result, that is y of t, may represent current or voltage in the network. Okay, very simple approach if you know how to determine the transfer function of a network. Right. So let me end this session here.